Hi guys, hope you're well. So today I'm going to be going through the June 2022 AS Paper 1 Question 11. It's a circles question, so let's get on with it. Part AI. Find the coordinates of the center of C. Now the first thing I notice is this equation here is the fully expanded version of the circles equation. We want it in its more useful form, which is the square version, as that tells us the square version tells us the radius and the center. We want the center, so clearly this version will help us. So let's get on with that. X squared plus y squared minus 10x minus 8y plus 32 equals 0. The first step is to group your terms together before we complete the square. So x squared minus 10x plus y squared minus 8y plus 32 equals 0. All I've done is move the terms around. That's all I've done. Haven't done no complicated algebraic manipulation. Just move my terms around. Next, I'm going to complete the square on the x terms only. So this would be x minus, you halve the coefficient of your single order, so your power of 1, which is x to the power of 1. So it's x minus 5 squared. Then we are adding on too much, which is the 5 squared. So I have to take that away. Plus y squared subtract 8y plus 32 equals 0. Now let's do the same with the y squared terms, or with the y variables. Complete the square with that. So x minus 5 squared minus 25 plus y minus 4 squared, because half of 8 is 4, minus 4 squared, which is 16, plus 32 equals 0. Now let's collect our like terms. X minus 5 squared plus y minus 4 squared plus, now you do 32 minus 16 minus 25, which is minus 9 equals 0. We move the 9 to the other side. X minus 5 squared plus y minus 4 squared equals 9. Now to find the center, think about a circle here. The center, the way I like to think of it, the center is at the point where the radius is technically 0. It's right here in the center. So if we draw a circle out again, the radius would be equal to 0. So think about this equation here. What would x and y have to be? What would x and y have to be? For the radius, usually the radius is represented by the right hand side. Equals radius squared. And 0 squared is just 0. So the radius would be 0. What would x and y have to be for the radius to be 0? Now how would we make x minus 5 squared equal to 0? Well, that would be x would have to equal to 5. And how would you make y minus 4 squared equal to 0? Well, y would have to be 4, because 4 minus 4 squared is equal to 0. So x would have to be 5, y must equal 4. And let's test that. If I substitute in 5 and 4 into these expressions, we get 0 squared plus 0 squared, which is 0. So the center, the coordinates, would be 5, 4. There we go. That's part A done. Part B, or part A, find the radius. Well, clearly from this, completed the square version, we get the center and the radius. Now, as I said, the right hand side is equal to the radius squared. Now, we could see that the right hand side is 9. So 9 equals the radius squared, or r squared. Therefore, r equals the square root of 9. So r equals 3. Radius equals 3. And there we go. That's part I done. Now part B. This is where most students struggle on. Find the shortest distance between the circle C and the line L. Now, first thing I notice is this format of the line. I don't want it in this format. I would much rather prefer y equals mx plus c, because that's more useful. So let's get into that format first before I do anything. So 2y plus x plus 6 equals 0. 2y equals minus x minus 6. Y equals minus half x minus 3. So clearly the gradient of this line is minus half. Okay. Now let's get back to the question. The shortest distance. Okay. Now in 2D space, which is clearly what this is on, because there's an x and a y coordinate, it's 2D. In 2D space, the shortest distance is usually a straight line. Now let me illustrate that. It's usually a straight line. So let's say I have a path. I'm over here. This is where I've started with. This is where I've ended up. So that's my start. That's my end. The shortest path from here to here is the straight path. Not this path. Not this path. Not this path. Not this path. The shortest distance is the straight line path. Is the path of least resistance. And this is the way I like to think of it in terms of this circle. So path of least resistance. So this question is asking us, find the length of the path of least resistance. So that would be a straight line from the circle to the line. But what we notice about this straight line is it must touch C. It has to touch C, and it must touch L as well. Now we are trying to find out the length of this section here, where the line just touches C and it just touches L. We are trying to find out that length. Now what do we notice about the distance from this point of the circle, the center, 4, 5, to the edge of the circle? Well, that's 3. Why is it 3? Because that's the radius. The radius is equal to 3. Think about it like this. If I had a circle here, the distance from here to here, here to here, here to here, here to here, it's all the same. That is the radius of the circle. And that is the same in this situation here. That's 3. Now, what I notice about this is a right angle. The reason it's a right angle is because think about this straight line that comes from C to L. If I was to do it not as a right angle, but let's say like this, or like this, or any other way, the line would be unnecessarily longer. You can clearly see that. I'm just adding extra distance for no reason. So a second point to make is preferably at a right angle. Another word for right angle is perpendicular. Now this is a key word, perpendicular. As in terms of straight lines, this tells us something. M1 times M2 equals -1. When I hear the word perpendicular, this springs to mind. Now this is useful because I know what the gradient of this line is. M1 equals -1/2. But if I was to find the gradient of this line and I know it's perpendicular, what I would have to do is take the negative reciprocal as M2 equals -1 over M1. Negative reciprocal. So that means take the negative of it and flip it. So M2 equals 2. Because -1/2, we flip it, we get -2. Take the negative, you get +2. So M2 equals 2. Now what I notice is that this line goes through 4, 5. So I can form an equation of a straight line. If I know that the coordinate is 4, 5 and the gradient is 2, I can just use the formula y minus y1 equals m, x minus x1. M equals 2 and it's 4, 5. Oh, my apologies. It's 5, 4, not 4, 5. But still, the point still stands. It was 5, 4. Y minus 4 equals 2, x minus 5. We expand that out. Y equals 2x minus 10 plus 4. A key point is get good at doing multiple steps in your head at a time. This comes with fluency and with practice. But each time you do a practice question, think, how can I skip steps? How can I make this step quicker? Can I combine steps? That's how it will happen. So y equals 2x minus 6. That comes from this. Now, there's two useful points I want to know. We see this and this. I want to find the length of that. I'll call it length. H. I'll call it h, the height. To find that, we need to find the intersection between the two lines. And preferably the edge of the circle, if we're going to do it that way. So first, let me try and find the intersection between the two lines. To do that, we have to do simultaneous equations. So y equals 2x minus 6. And the equation of L is minus y equals -1/2 x minus 3. Minus 3. Yep. So I'll call this 1. I'll call this 2. Sub 1 into 2. Or, because they're both y equals, or make 1 equal to 2. Because 2x minus 6 has to be equal to -1/2 x minus 3. Because they both contain y's. It's like this. If 1 equals to 2 equals y, which equals 1. Like that. So if A equals to B and B equals to C, then A equals to C. It's like that principle. So 2x minus 6 equals -1/2 x minus 3. Rearrange. 2 plus 1/2 is 5 over 2x equals 3. X equals 3 divided by 5 over 2 equals 6 over 5. Y equals, just substitute, so 2 bracket 6 over 5 minus 6, which equals minus 18 over 5. So the coordinate of this point here is 6 over 5 minus 18 over 5. Now, thinking about this point here, so let me draw that circle again. Apologies for the circle, but yeah. Thinking about this point here, that point is quite kind of difficult to find because I would have to use simultaneous equations with the equation of the line y equals 2x, I think it's minus 6, was it? Y equals, yep, 2x minus 6. And then I'd have to use this equation as well. That is quite a lengthy process. So let's think about it logically. Is there another way which I can find the shortest distance between L and the circle C? Well, what if, and I know that the length of this line here is 3. I want to find out what this is. Well, I know that this is 4, 5. And I know that this is 6 over 5 minus 18 over 5. What would happen if I try to find out the length of this whole line here instead? Then what could I do? So let me illustrate that more clearly. That's the length of the whole line, L. This is H, what we want to find. And this is 3. Now, if I can find out the length of L, how would I work out what H is? Well, if I do L subtract 3, which is rubbing out this bit, I get H. So if I can find out what L is, all I have to do is subtract 3 and I get it. And I get my answer. Now, the reason why this is beneficial in this case is because H on its own would be very complicated to find. So finding things in terms of what you already know is a useful trick in mathematics. Using the path of least resistance, we call it. So using the distance formula, so I have 4/5, which is where the center of the circle is, or 4/5. No, apologies, it's 5/4, not 4/5. I keep making that mistake, but 5/4. And then the second point, 6/5 minus 18 over 5, which is where the two lines intersect. Let's find the distance of that. D equals, or the size of D equals the square root of x1 minus x2. It doesn't matter which way around I take away, but it has to be consistent. Subtract plus 4 minus 18 over 5. Put that all into your calculator. 5 minus 6/5 squared plus 4 minus 18 over 5 squared, which is 361 over 5, square root that, 19 root 5 over 5. That's the distance of L, that whole thing L. Now to find H, I just do L minus 3. So do 19 root 5 over 5 minus 3. And does it say a form? Yep, it's just find the shortest distance. So this would be the answer. And that's it. That's how you would do it. You think of it in terms of what you do know. I know what the center of a circle is. I always know that. And if I can somehow incorporate that into what I'm trying to find or work out, it will always be beneficial to me. And plus, using that radius, which I already know is a simple value to work out. With maths, you don't want to do as many calculations as you can. You want to try and limit the amount of calculations you can. So hopefully that was useful. And hopefully you guys have enjoyed. If you have any questions, please do not hesitate to contact me either through my email, which I'll put in the description, or through the comments. Thank you guys for watching. Please like, subscribe, and hope to see you soon. Thank you. Take care.